Okay, so today we're going to talk about power. Power is an extension of work. So let's get right down to the definition. It's the rate of work done. So what is power? It is the rate of work done. Its symbol is a capital P for power. The unit we use is a watt, which is denoted by I think a capital W, which is super confusing because a capital W is also work. So that's super helpful. There's a few different equations we can use. The general equation is just power equals work divided by time, where work, right here, work, that is in joules because it's work, and time is in seconds, the SI base unit for time. Let's say we were going to be lifting something. So if we're lifting, we are working against gravity, okay? So our power is going to be, well, if work is force times displacement, then the force against gravity is mass times gravity. So we would do m times g times displacement, so mgs, which is our F times S, okay, just like in the work equation, okay, but then divided by time. So power against gravity for lifting something is mgs over t. And of course, if you're doing something at an angle, okay, then power is equivalent to force times displacement times cosine theta, just like work at an angle, Fs cosine theta, over time. Okay, so that's it. I think one thing I didn't tell you last class was that what a joule actually is. So 1 joule is equal to 1 Newton times meter, which is why F times S Newton meter, right? And a watt, so 1 watt is equivalent to 1 joule per second, because watt is power and power is work over time, joules over seconds. Okay, so just so you know, that's kind of a conversion for how you do power. Okay, so examples of power. Really just anything where you have something pushing, pulling, or lifting through a distance in a certain, which means basically measurable, amount of time. Okay, so that's all the power, and then we'll do one example problem on the back of this sheet underneath where you have already done your work examples. So if you will turn to the back of this page. Okay, so we have a power example. All right, so a machine lifts a 5,500 kilogram block 18 meters in 40 seconds. How powerful is this machine? Okay, so here I have something that's being lifted. So even though I know power equals work over time, I'm doing work against gravity. So I would say mgs for work, and then overtime. And they did give us the M, so we can plug that in. So 5,500, and it's in kilograms, which is the SI base unit. So this is your M, this is your displacement, and 40 seconds is your time. And you know what G is, but I wouldn't say it's negative, because if you're lifting it, it's going up, so it's the opposite direction. So I would just use the magnitude of gravity, 9.81, without the sign. And then S is 18 over time, which is 40 seconds, is the SI base unit for time. And you just plug and chug, right? So 5,500 times 9.81 times 18 divided by 40, and you get that number. So I'd round that number to like 24,300, just to make it easier on myself. And power is in watts, so it's a big W at the end, so 24,300 watts. Yeah. And that's it.